Binary operation. The word binary means two. Let us define binary operation. Binary operation star on a set A is a function from the Cartesian product A cross A to give A. We denote it as star A comma B by A star B. Binary operations mean combining two elements in a set to produce a third element that belongs to a set. Operations may be addition, subtraction, multiplication, and division. Let us discuss some examples to check this binary operation. Show that addition, subtraction, and multiplication are binary operations on R, but the division is not a binary operation on R. Also further show that division is a binary operation on a set R of non-zero real numbers. Let us examine first addition of real numbers is binary. R cos R giving R is given by A comma B to give A plus B. For example, 3 comma 2 to give 3 plus 2 which is equal to 5 which is also a real number. Next subtraction of real numbers is binary. That is, we have R cos R to give R is given by A comma B to give A minus B. For example, 3 comma 2 to give 3 minus 2 which is equal to 1 is also a real number. Next, multiplication of real numbers is binary. R cos R to give R is given by A comma B to give A cross B, that is A multiplied by B. That is, for example, 2 comma 3 to give 2 into 3 which is equal to 6 which is also a real number. Last, division of real numbers is not a binary for B equal to 0. We have R cos R to give R is given by A comma B giving A by B. For example, 2 comma 0 which will give 2 by 0 which is not defined. So anything divided by 0 is not a binary. Division of real numbers is a binary for B is non-zero. That is, R cos R to give R is given by A comma B giving A by B. For example, 3 comma 2 which will give 3 by 2 which is also a real number. For example, subtraction and division are not binary operations on natural number. Subtraction of natural numbers is not binary. N cross N to give N is given by A comma B to give A minus B. Giving example 3 comma 5 which will give 3 minus 5. So we'll get minus 2 which is not a natural number. Similarly, division of natural numbers is not binary. N cross N to give N is given by A comma B to give A by B. For example, 2 comma 3 giving 2 by 3 which is not a real number. Next we will learn the properties of binary operation. First we will check for the commutative property. A binary operation star on the set X is called commutative if A star B is equal to B star A for every A and B element of set X. Proof. Consider A comma B equal to 3 comma 4. For addition, we know A plus B equal to B plus A. That is 3 plus 4 is equal to 4 plus 3. Hence it is commutative. Now for subtraction, A minus B is equal to B minus A. We'll check. 3 minus 4 is equal to 4 minus 3. Is it correct? No. So minus 1 is not equal to 1. Hence it is not commutative. Now check for multiplication. A into B is equal to B into A. 3 into 4 is equal to 4 into 3. It's commutative. Now what about division? A by B is not equal to B by A. 3 by 4 it's not equal to 4 by 3. Hence division is also not commutative. Next, let us check for the associative property. A binary operation star on set A is defined as A star A to give is said to be associative if A star B within the bracket into C will be equal to A star B into C for all A, B, C element of set A. Consider A, B, C, 853. Check for the addition. We know A plus B plus C is equal to A plus B plus C. The order of bracket is important here. So, A plus 5 plus 3 will be equal to 8 plus then 5 plus 3. We get 16 on both sides, hence it is associative. Now, when we come to subtraction, A minus B minus C will be equal to A minus B minus C. Is it correct? 8 minus 5 minus 3 is equal to 8 minus 5 minus 3. And you will get 0 on the LHS and 6 on the RHS. That means 0 is not equal to 6. So hence it is not associative. Now comes to the multiplication. A into B into C will be equal to A into B into C. Here also the bracket, the order of brackets is important. So 8 into 5 into 3 will be equal to 8 into 5 into 3. You will get 120 on the LHS as well as the RHS. So hence it is associative. Now comes to the division. A by B divided by C will be equal to A divided by B divided by C. Is it correct? A divided by 5, then dividing by 3. Is it equal to A divided by 5 divided by 3? We will not get the equal answer. So hence it is not associative. Next we will discuss the identity property. Given a binary operation star such that A cross A to give A, an element E, element of set A, if it exists, is called the identity for the operation if A into E is equal to A, which is equal to E into A, for all A element of set A. 0 is the identity of addition on R. 1 is the identity element for multiplication on real number. For the operation A into E is equal to A is equal to E into A. Let's just check with 0 and 1. We know A plus 0 is equal to A, which is equal to 0 plus A. Now, what is A into 1, which will be equal to A, which is same as 1 into A. There is no identity element for subtraction and division. Now let's see the next property, that is invertible property. Given a binary operation star such that A cross A to get A with identity element E in A and an element A, element of set A, is said to be invertible with respect to the operation if there exists an element B in set A such that A into B is equal to E is equal to B into A. And B is called the inverse of A. It is denoted by A raised to 2 minus 1 and is pronounced as A inverse. Let's see the proof. A plus minus A, we get it as 0, which is same as minus A plus A. Similarly, A into 1 by A is equal to 1, which is equal to 1 by A into A. So, minus A is the inverse of A for addition on real numbers but not for natural numbers. Similarly, 1 by A is the inverse of A for multiplication on real numbers but not for natural numbers. With that, we have discussed the different properties of binary operation. Now, it's time to do a quick recap.
Manorama Horizon. Learning made simple.